Alright, so this is activity 7.3, comparing volumes. The volume V of a cube with edge length s centimeters is given by the equation V equals s cubed. So we can say this s with the exponent 3, we can say that is s cubed or s to the third power. So we're talking about volume, which is V, of a cube, which is a 3D square, and s is talking about edge length, right? So the edges of a cube, and then we're going to take that edge length and we're going to cube it. And just so you know, s cubed is the same as s times s times s. Okay. All right. So now let's go on to the second bit of information. The volume of a sphere is a function of its radius in centimeters. And the graph of this relationship is shown here. So we're talking about this graph here. So again, we're talking about volume of a sphere. A sphere is a 3D round ball. So a basketball, a volleyball, a baseball, right? Those are all spheres. And the function is going to be volume and the radius. So we have radius here, and that's going to be our input, our independent variable. And we can also consider that our x-axis. Okay, it all means the same thing. And then we have volume here, which is going to be our y, our output, and also known as our dependent variable. Okay, I would highly suggest making these annotations on your student workbook if you haven't already. All right, so question 1. Okay, question 1 wants to know, is the volume of a cube with edge length s equals 3 greater or less than the volume of a sphere with radius of 3? So the first thing we need to do, the very first thing we need to do is find the volume of a cube that has the edge length of s equals 3. So we're going to go back to our equation of V equals s cubed, and s being the edge length. And so we're going to substitute. So instead of s cubed, we know what s means. S is 3. So 3 cubed is 3 times 3 times 3, and that volume is going to be 27. So the volume of a cube we're talking about is actually 27. Okay? So is the number 27 greater than or less than the volume of a sphere with radius 3? So the next thing we need to do is find out what is the volume of a sphere when the radius is 3. So we're going to go over to our graph, and we're going to look at the input of 3. When the radius is 3, the volume is, and it looks like we're going to have to estimate a little bit. So if you look at the way our graph is scaled, it starts at 0, then 25, and we're talking about the volume axis, the y-axis. 25, 50, 75, 100, 125. So it looks like the volume is somewhere between 100 and 125. I'm going to go ahead and make a guess of 112. So now we can actually answer, is it less than or greater than? Is the volume of a cube, so basically is 27 greater than or less than the volume of a sphere with radius 3, which is 112. So we can answer that as less than. 27 is less than 112. And that is how we answer question number 1. Alright, I'm going to get rid of all this stuff so we can move on to the next question. So, question number 2. If a sphere has the same volume as a cube with edge length 5, estimate the radius of the sphere. So, if a sphere has the same volume as a cube, well, we don't know the volume of the cube, so that's the first thing we need to do. So the first thing we need to do is find the volume of the cube that has an edge length of 5. So again, we go back to our equation. V equals the edge length cubed. And we know the edge length is, this is the same as writing s equals 5. So we're going to substitute s for 5 cubed, which is 5 times 5 times 5. And that gives us a volume of 125. Okay. So I'm going to go ahead and actually just rewrite this sentence so we can answer it. If a sphere has the same volume as a cube with edge length 5, well, we know what that is. So if a sphere has, let's say, the volume of 125, because we know that's the volume that we're referring to, it wants us to estimate the radius of the sphere. So now we have to go over to our graph and look at our volume. So our volume is our dependent variable. It's going to be our vertical axis, our y-axis, and we have to find 125 on this graph. So we talked about scaling last time, so here's where 125 is. And we're going to follow it all the way to our function, and then we're going to estimate. So when the volume of a sphere is 125, the radius is somewhere between 3, and this would be 3.25. Somewhere between 3 and 3.25, I'm going to go ahead and say the radius is approximately, and that's how we denote approximate, 3.14. If you have something a little bit different but around that area, that's perfectly fine. Because we can see that the radius, that line we just dropped down, that dotted green line, is greater than 3 but less than 3.25. So 3.14 is a pretty good guess. Alright, let's move on to question number 3. So again, I'm going to erase all this. So question number 3. Compare the outputs of the two volume functions when the inputs are 2. So again, outputs are the same as our y or dependent variable. And we talked about that with question number 1. And inputs are the same as x or independent variable. Alright, so it wants us to compare the output when the two volume functions, when the inputs are 2. So if we look at the equation, v equals s cubed, v equals the edge length cubed, our input is going to be s. So our input is going to be s. Our output is going to be y. And we can remember that because the equation of a function is output is equal to the rule. So whatever variable we have by itself equal to some stuff is going to be our output. So we know that v is the output, and that means s has to be the input. So basically, when s is 2, what's v? And we're going to do that by substituting again. So s becomes 2, so 2 cubed, which actually gives us a volume of 8. 2 times 2 times 2. Okay. So if we look at our graph, what's the input? Okay, again, we're talking about the independent variable, the x-axis, so the input is radius. So when the radius is 2, what's the output, the volume? So again, we just go up here, and it looks like we're going to have to estimate again. So again, that line is 25. So it's somewhere between 25 and 50, but closer to 25. So I'm going to say the volume is going to be 28. Okay. So when the inputs are 2, the volume of a cube is 8, and the volume of a sphere is 28. And to compare the two, you can just comment that the volume of a sphere is larger. You can say that the volume of the sphere, or the volume of a cube is smaller than the volume of a sphere, things like that. So this is how you answer question number 3.